Alrighty, you guys. Good morning. Sorry I'm not in class today. I'm at a district planning day, so not on a beach relaxing, unfortunately, but I will be back in class tomorrow. So today what we're going to be doing is we're going to go through the 3.3 notes. This is where we're going to be drawing graphs of derivatives. It's not an exact science. It's a lot of our best guesses, our best sketches as we move forward here. And then hopefully you'll have enough time to finish your homework in class as well. All right, so let's look at example 1. So keep in mind our derivative of graph, we're going to be given our original graph in this one, and then we're going to use our slopes of our original graph to sketch our f prime. So the way I like to start here is to start by finding our zero slopes. So where in our original function do we have a slope that looks like it could be 0? My first instance right here, it looks like I have a horizontal slope right there. And maybe right here. Right, I'm going to start by plotting those on our f prime graph. So at -2, I think I have a slope of 0. And at +2, I have a slope of 0. Okay, then I'm going to try to find another point that I think is easy to kind of eyeball the slope. And I'm going to look right here at the origin. And this is when that estimation comes in. So that slope to me looks like we're going definitely negative, definitely decreasing. And if I continue the slope line, it looks like I'm going down 1 over 1. So I'm going to estimate that slope right there is -1. I'm going to plot that point. So f prime at 0 is going to give me -1. All right, now we're starting to get an idea what this graph looks like, but I need just a little bit more information. So I'm going to do my best job to estimate the slope going on right here at 4. So again, if I kind of continue it out, I'm going to make my best guess here. It looks like to me that we're increasing up 2 over 1. I'm going to estimate my slope right there is about 2. I'm also going to look right here, my endpoint there. I think it's the same. I think it looks like we're increasing 2 and going over 1 about. I'm going to estimate my slope right there is also 2. Like I said, you guys, this is not an exact science. We're just taking our best swing at it. All right, so when we plot those on there, so at about 3.5, I'm saying my slope is about 2. This should be enough information to sketch our graph. Okay, so that's my sketch of f prime. Some things to keep in mind. Remember, when we take the derivative of something, the degree goes down 1. So if we were to start with a cubic, which is what we're looking at here in f, it's definitely a cubic. When we take the derivative, it's going to end up being some type of quadratic. We always go down a degree, and that can help us with these sketches. We already knew that our sketch should end up looking something like this, and that'll help us out. All right, let's try number 2. Okay, let's go ahead and look at the second example. So our second example is very different than our first. This time we are given our f prime line, and we have to extrapolate as much information as we can from f prime to give our best sketch of f. It's kind of iffy work here. It's not going to be exact, but we're just looking for as much information as we can to give our best sketch of our original function. So my approach to this is we're going to make an f prime line that summarizes when our f prime graph over here is positive and negative. And then we're going to make our f double prime line based off our f prime line. So let's start just talking about when is our f prime line positive and when is it negative. So this whole section in green is our positive section. And then we move into the negative realm right here at 0. So that's the information we need to build our f prime line. Our important point that we switch from positive to negative is 0. So from -3.5 to 0, we're positive. And from 0 to 3.5, we're going to be negative. All right. So what this tells us about our f line is it tells us we are increasing from negative 3.5 to 0, and we are decreasing from 0 to 3.5. It also tells us if we're increasing and then decreasing that we have a local max at x equals 0. So lots of good information there. All right, now let's try to move on to our f prime double prime line. So to get our f double prime line information, what we're going to do is look at this graph's slope. It's the derivative of f prime, so we're going to be talking about the derivative, the slope of f prime. All we really care about is when our slope is increasing and when our slope is decreasing. So starting here at negative 3.5, it definitely looks like I'm going uphill, I'm increasing until I hit negative 2. Then I start going downhill, I start decreasing until I hit positive 2. And then once again, I'm increasing up to 3.5. So these points, negative 2 and 2, where we switch from increasing to decreasing, are going to be our POIs. So I'm going to go ahead and make our f double prime line now. Our POI points are going to be negative 2 and 2. And we know our second derivative is positive in these sections and negative in the middle. All right, now that we've constructed our f double prime line, let's talk about what it means for our original graph here. So for our original graph, we know that we're concave up in the sections negative 3.5 to negative 2, and when 2 to 3.5. It's going to be our concave up. And then we're going to be concave down from negative 2 to 2. We also have points of inflection at x equals plus minus 2. So now that we have all this information about our original, we can give a pretty good sketch. There's also one other given that's very helpful. This one gives us a starting point. So we know we're starting at 0, 1. All right, I think the next step that'll make this as easiest is to look at our concave down section. So you remember concave down is like a sad face. We're not exactly sure how thin it is or how wide it's going to go. We just kind of know it's a sad face that has this maximum point of x equals 0. So this is our highest point on the graph. And we're going to be making that concave down up until 2 and negative 2. Now let's look at our concave up. So we should be like a smiley face on this side and a smiley face on this side, right? Those are our concave up sections. Now let's double check to make sure these agree with our increasing and our decreasing sections. All right, so we should be increasing from negative 3 to 5 to 0. So you can see I kind of made an error here that I have one little section that I'm decreasing. So I'm going to adjust so that I'm always increasing. Okay, now I'm always increasing. I'm in the same problem over here. I should continue to decrease here. Sorry, erase my line there. There you go. So now I continue to increase all the way up until my maximum point, and then I start decreasing all the way down nonstop to my last point on either side. That's my good sketch. It's not perfect. A lot of good information on there. All right, let's try our last example here today. So in this one, I'm given my f prime line, and it's asking me to draw my original and my second derivative. So first, I'm going to start by drawing the second derivative. Now remember, our second derivative is the slope of our first derivative. So I'm looking for what the slope of these lines are. So I can choose any point on my f prime line. I'm going to choose right here at negative 3, and I can see my slope here is up 1 over 1. So m equals 1, and that stays true all the way up, right? I have this constant slope all the way up. So at negative 3, on my f double prime line, I'm putting a point at m equals 1. And that's true at -2, and it's true at -1, and so on and so forth. Now, this shouldn't surprise us because this is a linear line right here in f prime. And if we take the derivative of a linear, we end up with a constant. We're looking at this constant 1. Now, we have this kind of iffy situation where we're going to all of a sudden stop and change directions really sharply here at x equals 0. So I'm going to leave that an open dot for now. Now let's try to figure out our slope of the second part, our quadratic part over here. So first I'm going to look, what do I think the slope is? Let's say right here. Looks like to me we're looking at about 1. So at x equals 1, I think the slope here is 1. Let me check another point. Maybe what's going on right here at x equals 0. Do we see that should be a horizontal asymptote right there? Flatlining, so our slope would be 0. Maybe let's check one more point to get an idea what this graph looks like. Let's try up here. So it definitely looks like my slope is increasing the further we go. I'm going to say that slope looks like about m equals 2. About a slope of 2. Oops, wrong spot. All right, so what we're looking at here is a linear progression on our f double prime line. Okay, so by looking at the slope of our f prime line, we have now found our f double prime graph. All right, now we're going to try to find our very best possible graph of f. To do that, we're going to summarize our information of f prime and f double prime on f prime and f double prime lines, and then take that information and try to compile it onto our original graph. All right, let's start by looking at our f prime line. So again, all we care about right now is where is it positive and where is it negative. So it looks like we're negative all the way up until we hit -2. And then we get into that positive world all the rest of the way. Okay, so when we talk about our f prime line, we really have this one possible extrema right here at -2. On the left-hand side, we are negative. And on the right-hand side of that, we are positive. All right, now let's talk about what that means for our original graph f. So what we know is we are decreasing from -infinity to 2, and we are increasing from -2 to infinity. So if we're decreasing, hit -2, and then increase again, we should be able to see this as a minimum. So we have a relative min at x equals -2. All right, now let's talk about our f double prime line. Now again, we care when our f double prime is positive and our negative, when our second derivative is positive and negative. So looking at our f double prime line, I see that we are positive the entire time, right? We never go into that negative realm on this graph. The one funky thing that we have going on is we have a jump going on right here at x equals 0. So when we're building our line, we're going to say there might be something funky going on there at x equals 0, but either side is still positive, which means we're going to be concave up on either side of that 0. Oh, sorry, I said concave up and then drew concave down. Pardon me. We're going to be concave up. Okay, now this is going to tell us for our original graph that we are concave up from negative infinity to 0, and then from 0 to infinity. So we might have like a little break in the graph of maybe a very sharp turn going on there at x equals 0. Okay, now here comes the not exact science part. We're going to do our very best to represent all this information on our original graph. Now this word possible tells us there is multiple answers that are correct in this equation. So we're just going to give one of the possible answers here. Now notice it doesn't even give us a start point. So we're going to know that there's an infinite number of correct answers here because we could technically start anywhere on the graph. All right, so the first place I'm going to start here is keeping in mind that we are concave up at all times. So I should always be keeping these shapes throughout the graph. Then I'm going to look over here and tell myself that I have a minimum at x equals -2. Now it could be at -2 and 1. You could choose to start at -2, -100. I'm going to choose to start right here. I'm going to call this minimum -2, -1. Now I know on the left-hand side, I'm decreasing and concave up. So that might look something like this. And on the right-hand side, I'm increasing and still concave up. Okay. So I've hit all that information in there. I have my concavity correct. I have my decreasing, increasing intervals correct. So this is a possible graph of f. Okay, guys, once you're done watching this video, I'm going to have you watch this video from Khan Academy, give one more example of getting from a graph to an antiderivative of the graph. And then you should use the rest of class to do homework 3-3. Now keep in mind, these ones can be a little frustrating because they're not these exact answers, right? There's some guesswork in here. We're doing our best sketches. So just give me your best go at it and we'll talk about some of these tomorrow. In class tomorrow, I'll be checking 3-1, 3-1, 3-2, and 3-3, giving you some homework stamps. And hopefully I'll be able to address any homework questions you have left over.